In this problem, we want to find the consumer surplus at a price of $5 per pizza for the price-demand equation d of x equals 10 minus 0.02x. So, when we approach this problem, the first thing that we should note is the formula for consumer surplus. We say CS, or consumer surplus, is equal to the integral from 0 to x bar of the quantity of d of x minus p bar dx. And now that we have this integral set up, let's go ahead and plug in whatever information we already know so we know what's left to solve for before we can integrate. So to start off with, we were not given x bar. X bar represents the quantity sold, which was not told to us. But we were given d of x, which is 10 minus 0.02x. That's our demand equation. So we'll plug that in. And then from here, we were given p bar. P bar is our unit market price, or in this case, the price per pizza, which is $5. So we're going to subtract p bar, or subtract 5, and we're integrating this with respect to x. So we put our dx at the end. From here, we can just quickly simplify, which gives us the integral from 0 to x bar of 10 minus 5, if we combine our like terms, gives us 5 minus 0.02x dx. Now that we have this, all we have to do is solve for x bar, and then we can perform our integral. So, it's important to remember that whenever you're dealing with consumer surplus and you're given the unit market price p bar and you're given the demand equation d of x, then it is true that p bar is equal to d of x bar. The reasoning for that is p is equal to d of x. That's not very good. D of x. So if you plug x bar into your demand equation, or if you plug the quantity sold into the demand equation, you'll find out what price was used to get that quantity sold, which is p bar. So that's how we get this equation here. And we know these values. P bar we said is 5, and that's equal to d of x bar, which literally means just take x bar and plug it in for x in your demand equation d of x. So we get 10 minus 0.02 x bar. And now this is just a basic linear equation that we can solve for x bar, just as if we were solving for x. We'll start by subtracting 10 from each side, giving us negative 5 equals negative 0.02 x bar. And then if we divide each side by negative 0.02, we're left with x bar equals 250. So that's our quantity sold when we have a unit market price of $5 per pizza. So we get the integral from 0 to x bar is now the integral from 0 to 250 of 5 minus 0.02x dx. And now we need to take our antiderivatives. So, because we're subtracting these two terms, we can take the antiderivative separately. So we'll start with the antiderivative of 5. Remember, whenever you have any constant by itself, its antiderivative is automatically 5 times the variable that you had with your d of x. So in this case, x, if it were dt, it'd be t. If it were du, it'd be u, and so on. So the antiderivative of 5 is 5x minus 0.02 x to the 1 plus 1 over 1 plus 1. So remember, whenever you have an x, the antiderivative is when you add 1 to the exponent. So this is our plus 1, and then divide by your new exponent. And we're integrating this from 0 to 250. Okay, so from here we're just going to simplify this down a bit, and then we can plug in our limits of integration and solve. So we have 5x minus 0.02x squared over 2. And we're integrating from 0 to 250. And then from there we can simplify this a bit more to 5x minus 0.01x squared. And we're integrating that from 0 to 250. So now that we have this simplified, let's plug in our values, our limits of integration, which gives us 5 times our top limit, 250, minus 0.01 times our top limit, which is again 250, and we're squaring that 250. And then we're going to subtract when we plug in our bottom limit of 0. So we get 5 times 0 minus 0.01 times 0 squared. And when you plug all of this into your calculator, you'll get 625. So, because this is a story problem, we want to go ahead and give a sentence answer here. So we'll say the total savings to consumers willing to pay more than $5 per pizza is $625. And that is our answer to our original problem.